Okay, you should have attempted your warm-up at this point. It says, given the piecewise function, blah, answer the questions below. Evaluate f of 1. To do f of 1, we're going to plug the 1 in where it's equal, because it's equal to 1 right there. So we're going to plug it into 3x squared plus 11x plus 1. So 3 times 1 squared plus 11 times 1 plus 1. That'd be 3 plus 11 plus 1. 14 plus 1 is 15. So you should have got 15 for number 1. Is f of x continuous at x equals 1? Well, how do you tell if something's continuous? If you could see me, I would be putting my hand from the left, has to come in to my hand to the right, and it has to equal. So to prove something's continuous, you have to say that the limit as x approaches 1 from the left has to equal the limit as x approaches 1 from the right has to equal f of 1. So these are question marks right now because I don't know. So let's evaluate each one. The limit as x approaches 1 from the left, I would plug it into the top because my arrow is going this way. So that would be 1 cubed plus 14 times 1. 1 plus 14 is 15. So that one's 15. The limit as x approaches 1 from the right would be the bottom. So that's 15. F of 1 is 15. So is it continuous? Yes. If it asked you to justify your answer, this would be it right here. Find f prime of x. Ooh, tricky one. Oh, look, there's more. Oh well, do this now. Pause. Unpause. Okay. Find f prime of x. To find f prime of x, you're like, oh gosh, how do I do this? Well, you just take the derivative of the top and the derivative of the bottom. So the derivative of the top would be 3x squared plus 14 if x is less than 1. And the bottom is 6x plus 11 if x is greater than or equal to 1. Does f prime of 1 exist? Well, in order for the derivative to exist, the derivative as x approaches 1 from the left has to equal the derivative as x approaches 1 from the right. And actually, let me do it in proper notation. You would say the limit as x approaches 1 from the left of the derivative equals the limit as x approaches 1 from the right of the derivative. They have to be the same. So as x approaches 1 from the left, I would stick it in the top. 3 times 1 is 1. So 3 times 1 is 3, plus 14 is 17. And then this one, 6 times 1 is 6, plus 11 is 17. So that means we know it's continuous. We know that the derivatives are the same from both sides. So does it exist? Yes. Yes, it does. And it's 17. And then true or false, the limit as x approaches 1 of f of x equals 17. Well, no, we've already determined that that's 15, so that's false. So hopefully you got those right. Make sure Deja's checked you off for the 20th. This is warm-up 920. And so y'all should watch the video on 3-4. If you don't understand me, go watch the guy on 3-4, and then we'll come back and we'll talk about it on Monday, and I hope y'all have a great weekend.